Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends, to your younger brothers and sisters who would want to take up engineering in the future, and to your relatives. That's one way you can keep me going, inspired, and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Hello students, future engineers, subscribers, and viewers. There is another problem in calculus, particularly on derivative as interpreted as instantaneous velocity or rate of change. I hope that you will enjoy watching and you learn from the solutions to this problem. And if you want to anticipate the solution, you can by pausing the video. Do not look at the presented solutions here. Part 1, the cost in dollars of producing X units of a certain commodity is given by C function of X. Cost as a function of X is 5,000 plus 10X plus 0.05 X squared. Part A, find the average rate of change C with respect to X when the production level is changed AI from 100 to 105 units. Then 2 from X equals 100 units to 101 units. Then B, find the instantaneous rate of change C with respect to X when X is 100. So this instantaneous rate of change of the cost is called the marginal cost in economics. So for part 1A, uh, this is delta C over delta X. Then delta C is simply the cost when X is 105 and less the cost when X is 100 divided by 105 minus 100, which is 5. And that is the same thing for the second part, but we replace X by 101. So for final and 100 for the initial. So delta C over delta X is when X is 105. So substitute into this formula here. 5,000 plus 10 times 105 plus 0.05 of 105 square minus when X is 100, quantity 5,000 plus 10 times 100 plus 0.05 times 100 square divided by delta X, which is 105 minus 100. Therefore, the average rate of change of Z with respect to X is equal to $20.25 per unit. So you just look at the numerator, that's cost, so that's in dollars. Delta X is number of units, so per unit. Then for part 2i, X 100 to 101, the same. We replace X here by 101. Then 5,000, that's 100. So we get divided by 101 minus 100, we get $20.05 per unit. So we suspect that the answer, as delta x approaches 0, that's derivative of cost with respect to x. So we suspect that the answer is 20. So let's check. Derivative of cost function with respect to x is from here, derivative of 5,000 plus 10x plus 0.05 x squared is 0 because that's constant. 10 plus 0.05 times 2x, that's 10 plus 0.1 of x. So that's the instantaneous rate of change of z with respect to x, or the marginal cost. So when x is 100, 10 plus 0.1 of 100. So the instantaneous rate of change of z is indeed $20 per unit. So let's proceed to the second problem. If a cylindrical tank holds 100,000 gallons of water which can be drained from the bottom of the tank in an hour, then Torricelli's law gives the volume V of water remaining in the tank after 30 minutes as this equation here, volume as a function of time, 100,000 quantity 1 minus T over 60 quantity square, where T is 0 less than equal to T less than equal to 60 as the domain of T. So imagine a cylindrical tank with capacity 100,000 gallons. So obviously, the rate at which water will be flowing out is fastest at the start, even if we do not solve it yet. Then as the water level drops, the head is, or the distance of the opening outlet to the liquid surface decreases, so the rate of flow would be decreased also. That's the expected situation. So find the rate at which water is flowing out of the tank, the instantaneous rate of change of volume with respect to T. So we differentiate this formula expression. And what are its units? For times T 0, minute, 10, 20, 30, 40, 50, and 60 minutes, find the flow rate and the amount of water remaining in the tank. Summarize your findings in a sentence or two. At what time is the flow rate the greatest? So I think we can answer this at time t equals 0, and the least, of course, when the time t is 60, when there is no more water in the tank, or when the last drop of water flows out. So volume is 100,000, quantity 1 minus t over 60 square. So rate of change, we differentiate this. So constant, copy, then this is derivative of u square. Imagine this is u square. 1 minus t over 60 is u. So power formula 2 times quantity 1 minus t over 60 raised to 1. Then the derivative of 1 minus t over 60, of course, 0 for 1. Then negative 1 over 60 for negative t over 60. Simplifying, dv dt or v prime is negative 100, negative 10,000 over 3 times quantity 1 minus t over 60, distribute. So dv dt v prime is 500 t over 9 minus 10,000 over 3. And the units would be gallons per minute. Volume, gallons, time per minute. So that's the answer to 2 part 1, part A. Then for time equals 0, the rate of change, we just substitute 0 here. So negative 10,000 over 3, and that is negative 3,333.33 gallons per minute. The volume remained at that instant when time is 0 is intact, the capacity of the tank, which is 100,000. Or you just substitute T equals 0 in this formula. So you'll get 100,000 gallons. When T is 10, dvdt is, substitute here, 500 times t 10 over 9 minus 10,000 over 3 will get negative 2777.78 gallons per minute. So rate of change is negative, means the volume of water remaining in the tank decreases. So that's why we have a negative sign. That's the meaning of that. The negative sign indicates that the volume remaining in the tank is decreasing, or the volume is decreasing in the tank. So volume remained 100,000 into the formula. Quantity 1 minus 10 over 60 square, we have 69,444.44 gallons. Then when t is 0, dv dt is 500 times 20 over 9 into the formula. Minus 10,000 over 3, you'll get negative 2222.22 gallons per minute. Volume remain 100,000 times quantity 1 minus 20 over 60 square. We get 44,444.44 gallons. Then when t is 30, into the formula, you'll get negative 1,666.67 gallons per minute. Volume remains, substitute t is 30, you'll get 25,000 gallons. When t is 40, so you just verify, you just substitute into the formula. Negative 1,111.11 gallons per minute. Volume remained into the formula also here. T is 40, 1,111.11 gallons. It's just that the magnitude are the same, just a coincidence. Then T is 50, dvdt negative 555.66 gallons per minute. So as the time increases approaching 60 minutes, the rate of change of volume is decreasing, it's lowering. So we suspect that that's why at time t equals 0, it is now, rate of change is now 0, because there's no more water in remaining in the tank. So volume remained when T is 50, 2777.78 gallons. When time is 60, it's dVdt 0 gallons per minute, and volume remained is also 0. So these are the findings. The rate at which water is flowing out of the tank is fastest at the start and slowest or 0 at the end. That's why the rate of change decreases when T increases. So T0, the flow rate is greatest. T60, the flow rate is least. So that's it for this video.